In this video, we will cover topic 3.2, percent composition. The percentage of each element found in a compound will be constant regardless of how large your sample size is. So for example, the percent of hydrogen by mass in water will always be the same whether you have just 1 gram of water or 1,000 grams of water. This equation for percent composition is on your periodic table in the miscellaneous equation box. So here on the back, and it's this first equation right here, where the mass percent comp meaning composition, is equal to the mass divided by the total mass. And that means the mass of the element in question divided by the total mass of the compound. Here is an example problem. If analysis of a 10-gram sample gaseous compound showed it contained 2.5 grams of hydrogen and 7.5 grams of carbon, the percent composition is calculated as follows. You will take the 2.5 grams of hydrogen divided by the total 10-gram sample times 100 to equal 25% of hydrogen. And then the same for carbon, 7.5 grams of carbon divided by the total 10-gram sample times 100, and you have 75% of carbon. All the percentages should equal 100%. Now try this problem. So here we have the 7.34 grams of carbon in the numerator here to find the percent of carbon, with the total 12.04 in the denominator. And then times 100, and we have 60.96% of carbon. And then do the same for the mass of hydrogen divided by the total, and then the mass of nitrogen divided by the total. All of these percentages should equal 100%. Let's try another one. Aspirin is a compound with the molecular formula C9H8O4. What is its percent composition? Because we aren't given any sample data in this problem, we will be using the molar masses of each element to solve. First, let's find the molar mass of aspirin. So if you add up the mass of 9 carbons, 8 hydrogens, and 4 oxygens, we get a mass of 180.154 grams per mole. This is the total mass of the compound that will be in the denominator of each of our equations. To find the mass of carbon, we notice that there are 9 carbons in the compound. So we take 9 times the mass of carbon. 12.01 is the molar mass of carbon found on the periodic table. We're going to divide this by 180.154, then times that by 100. And we can do the same thing for hydrogen and oxygen. For hydrogen, because there are 8 of them, we're going to take 8 times the mass of hydrogen. 1.008 is found on the periodic table as the average atomic mass for hydrogen. Divide this by the total times 100, and you'll find the percent of hydrogen. And then lastly, for oxygen, we have 4 times the mass of oxygen. 16 is the average atomic mass for oxygen. Divide this by the total, and you would get the percent of oxygen. Here are the answers. Notice again that all of the percentages do in fact equal 100%. This is a problem on the practice problem set 3.2. This is problem 1. What is the percent composition of FeO, or iron 2 oxide? We have the molar mass of iron and oxygen listed here. Those are just straight from the periodic table. And then if you add up 1 iron and 1 oxygen, we have the molar mass of FeO as 71.844. Because we only have 1 iron in the compound, we're going to use the mass of 1 iron in the numerator. And then the denominator is the total molar mass times 100, and this is your percent for iron. And then same thing for oxygen. We only have 1 oxygen in the compound, so we will divide the mass of 1 oxygen divided by the total times 100, and we have a percent of 22.27%. And now you can complete all of the practice problem set 3.2.